only in our group, what? They shouldn't come in. Can I start now? Start. No such person.
No. That's my mother.
Just. Oh.
Wait, she's entering the room or the face? Oh, what?
Can you can ask her, but please ask her to listen and enjoy, huh?
Okay.
No talking. Yeah, sure.
Yeah.
Welcome. Okay. So a very good evening to everyone here. So this is our astronomy picture of the day presentation on the 27th of August by the Astronomical Society of Penang. And again, we have our young members, except myself, who are presenting. First of all, I want to thank our Astronomical Society of Penang Treasurer, Mr. Michael Teo, who hosts this event. All right. And also our member, Mr. Lai, who is now studying in Beijing, who selected the pictures. Thanks, Lai, for selecting. And because our young member, Rayan, all right, Rayan stays in Kuala Lumpur, our capital city of Malaysia, and he's going to pursue his studies in Australia soon, university studies. And of course, our Yun Meng also is our Penang very keen astronomy enthusiast, all right. And Yun Meng also will be pursuing soon his uni studies in UK. And of course, we all want to commend our member Boon Wei also. Boon Wei is working in Penang. Okay, I'm of course retired already, but still a lot of fun going on. All right, so we can start now. I will select my first picture for APOD for this month, August 2023. Okay, wait. A bit slow. Lower, just wait. I don't see anything here. Because under Chroma, it's a new format, new style. I'm not very familiar also now. Let's see, I can share or not. Any comment, Rayan? Why like that? I'm trying to click on the share tab, but I don't see any action.
How interesting.
Interesting, huh? Now you have this Chrome always updated software.
What happens to what happens when you click present? Nothing at all.
Nothing. So I click share, also got nothing. Okay. So now I will click, of course, this APOD for August. Let me look at APOD for August. Just wait a moment. Wait, Okay, we go to APOD for the line is actually very fast today for me, but I just cannot share the Google what you call. Try again. Same thing. So what should I do, Rayan? Let me see.
Is it just the picture that you're trying to share, or are there some...
No, it says share or cancel. So right now the taskbar is on cancel. I press share, nothing happened. So
or you can share the entire screen,
Yeah, I have Chrome tab, and then window and entire screen. So what do I do? Press, I see entire screen. Now I got it. Oh, there's a new format. Now I get it. Thank you, everyone. Thank you, Michael. So can't share your screen. I dismiss. Dismiss. Yeah. Okay. Wait. Can you see my screen now, everyone?
No.
Good. How come? It says stop sharing. Okay, I click stop sharing now. And then I go back to share again. Entire screen. Yes. Share, yes. Click share again. Hide.
There we go.
Okay. Now, thank you. Can see, Okay. A few minutes delay. So we start with, because Rayan and Boon Wei and Yun Meng, because in Malaysia we say 27th of August 2023, but here we follow a more accurate way, 2023 August 23rd. All right. So the first one is of course by our so nice. We show the full picture first. Okay. By the famous Miroslav Druk Muller, the professor of mechanical engineering in the university in Czech Republic, and he's the one who actually came up with the fantastic processing of the corona of the total solar eclipse, right? So let me go into a smaller picture, okay? And this, by the way, is taken in 2007, all right? So the name is Three Galaxies and a Comet. There are three galaxies. Of course, what is our Milky Way, large Magellanic Cloud, and small Magellanic Cloud. And the comet is actually Comet Magnot, but it was in 2007. That means Professor Duke Muller must have recently went into his old record and found this wonderful picture. And he found that it's still good to put in APOD, and APOD accepted it. So it's a bit late, 2007. This book, I really like it. And please look at the tail of the Magnot, so bright curve, you know. It looks like a fin of a shark, you know. So some of the picture where the head of the comet went below the mountain, only the tail poke up through the mountain. So nice, all right? So basically, the Milky Way and the two, it's actually not three galaxies. The large and small Magellanic Cloud, I call it the sidekick lah. Because the big brother is Milky Way and the sidekick is large and small Magellanic Cloud, okay? And of course, Comet Magnot. And look at the picture, so nice, you know. Taken, of course, in Patagonia. So he traveled all the way to Patagonia. Where's Patagonia? It's in the remote southern tip of Argentina, near to Antarctica. Must be very cold. And he took it really, really nice, all right? So basically, good location, good weather, and a famous astrophotographer, Professor Miroslav Drückmuller from Czech Republic, okay? So I will show the second picture now, 23rd. This is, we know recently we have our Penang, we have our Perseid meteor shower. So you have the bright meteor, you look carefully, it's basically from the bottom left to the upper right, all right? And then you see here, it's a meteor in the galaxy by our, since it's a Spanish guy, I will pronounce his name in Spanish, learn a bit of language, our Señor Jose Pedro Barrios from Spain, all right? The meteor and the galaxy. Where's the meteor here? The galaxy is, of course, here. I've got the galaxy here is Andromeda Galaxy, all right? In the Andromeda constellation, all right? So once you look at this picture, you know, oh, look carefully. There's a thing like sticking out from the tail of comet. So that this means that it's a long exposure. If it's a short exposure, you only see a flash of light. Because I don't know how long, maybe many seconds or maybe up to a minute. Then you can see this thing here. This is called the persistent train. That means when the Perseid meteor in the upper atmosphere, and after maybe about a few seconds, the wind up there will blow, and then it forms like a trail here. Just like, imagine someone is smoking a cigarette in the garden of the house. It blow up the smoke, and the smoke will start trailing away. So this is the trail. It shows that it's not an instant shot. It's a slightly longer exposure shot, right? And basically, you know, it's the dust and ice particle from the comet sea turtle orbiting the sun once every 133 years. And the orbit of this comet intersect the orbit of the Earth. And when the Earth enter into this part of the meteor stream, it comes from the constellation of Perseus, all right? And I would say the Perseus meteors are medium speed, about 59 kilometers per second. Wow, so fast. Now, we know that in astronomy, anything in space, even the Earth's orbit around the sun, is very fast, many kilometers per second. So this 59 kilometers per second is medium speed. The slow ones are, for example, you have this Gemini meteor shower, but the fastest is what? Leonid meteor shower, 71 kilometers per second, all right? So this is our bright meteor trail of one of the Perseid meteors, okay, taken by Señor Jose Pedro Barrias, okay, from Castilla-La Mancha, Spain, all right? Very nice, all right? The meteor right next to this Andromeda Galaxy. The next picture is 21st of August. This is going to be a super hit, you know. Nishimura, not a man or person to comment. We saw recently that, I think on the 12th of August, that there's a Hideo, what do you call, Nishimura, a Japanese comet hunter. He's a comet hunter, no? He was lucky. He was using, outside his house in Japan, a Canon 6D camera with only 200 mm telephoto lens. No telescope. and he only had chance to take 30-second shot for 3 times, and he got it. All right. So of course, on the right side is the star, on the left side is the nucleus of the comet, and you can see the tail there. Okay. Okay. Why is it? You have the coma is like this. You have a frozen nucleus of the comet coming from far outside the Oort cloud, entering the inner solar system, and it's actually going to be as close to the sun inside the orbit of Mercury. Not yet. So it's going to pass by the Earth on 13th of September. So in that case, the sun's heat and light, all right, and solar wind will hit onto the frozen nucleus and evaporate it to form the coma. And because this comet is still moving, all right, so it will give a tail, all right. So basically, the straight tail is formed by the solar wind, all right, and this expanding coma is by the heat and the energy of the sun expanding it. And if you look at the comet like that, everyone look at this, Bunwei and Yunming and Rain. Where is the comet moving? Dr. Chong, from the right to the left? No. You look at the comet here, the tail is touching away to the right, so therefore the comet is moving to the left. No. You must see where is the sun. So actually, if imagine the sun is to the left, the comet is not going to the left to the sun, that means you crash to the sun. It could be moving towards the upper left or the bottom left, or it could be even moving to the upper right or in the bottom right. So we must know its orbit. So it doesn't mean that you look at the comet this way, the comet is moving to the left. No, you must know where's the sun, and if you know the previous location, let's say previously the comet was here, the coma was here, today is here. Oh, the comet is moving like that. Okay, like that. So very nice picture of Nishimura, and of course, many of the amateurs in the world are saying they already observed it, I think yesterday, at magnitude 7.2, not yet naked eye. So they are predicting at maybe first week of September, can see with our own eyes. So right now it's in Gemini constellation. We hope it can be seen, but it won't be a very bright comet lah. But we hope that at least can be seen. And then many people, amateur astronomers, astrophotographers, including our members in Penang, in Malaysia, will go gaga and go to a deep, dark location to take. And by the way, just to let you know, our member Kenny Low and our William Chin and some members, 10 of them, they're going to Kuala Kubu Baru next week to image this comet. So we hope, I wish them all the luck, and also got good weather. Good weather. So this is introducing comet Nishimura, and we hope in future this also will cause a meteor shower. Okay, so I pass to our next presenter, Ryan.
Okay, thank you, Dr.
So what I'm there. Okay,
let me try.
You're on, Ryan.
Let's see if presenting works on my end.
Take your time.
Let's get the right one. Okay, it should be this. There we go.
I always like the backdrop of Ryan and Bunwei. Very nice backdrop.
Okay, can you see?
Not yet. Yes, I see. Wow, look at this.
Let me.
Wow, is it the end of the whole movie?
Oh, perhaps it is. Can you still see the picture here?
I can see. Wonderful.
Okay.
I already know what it is. Wonderful.
It is. It is absolutely wonderful. In fact, Dr. Chong, you mentioned how one of your earlier pictures was actually taken a few years back. This one was also taken a few years back at around 6:52 p.m. on the 1st of June 2007 in downtown Racine, Wisconsin. The USS Enterprise descended from the 23rd century and visited us, sharing with us the medical technology that we use to cure COVID-19.
Wow.
Or at least that may have happened in some alternate universe. What we really had was this picture here, taken by Megan Hanrahan. She's a Montreal meteorologist who uses the pseudonym PeerCB on Wikipedia Commons. And she took out her Sony DSC W70 and captured this terrifying shot.
Mm-hmm.
Now, what we have here is a prime example of an Arcus cloud, or more specifically, a roll cloud. Let's quickly review what we know about thunderstorms. When warm air from the lower atmosphere rises up, it creates an updraft. These powerful air currents evaporate water from the Earth's surface and pushes the moisture to heights between 500 to 1600 meters in the air. And they form a type of cloud known as the cumulonimbus. Now, as this updraft carries more and more water vapor, the cloud builds in size, sometimes reaching heights of over 15 kilometers. In addition to building in size, the clouds also start to darken as they gather more water, until eventually the cool, near moistureless air from the upper atmosphere pulls the moisture back to the ground in a downdraft, creating rain. Now, an Arcus cloud accompanies these cumulonimbi, forming at the front of the larger thunderclouds. Roll clouds specifically are the result of the cool downdraft pushing the warmer, humid air upwards, causing them to cool into magnificent rolling beasts. In fact, and I'm not kidding, they actually do roll. In fact, I have a quick clip here
Wow.
of rolling clouds. I've
Ui.
muted it, but just look at how those clouds roll. They really are rolling. They're rolling around a horizontal axis, as you can see right there,
Yeah.
rolling backwards. It's just beautiful.
Luckily, it's not a tsunami.
Luckily, yes, absolutely. So yeah, back to the
Fantastic.
picture here. Now, these events are rare. However, and this is just a quick thing I wanted to share, there are actually rows of rolling clouds that are quite predictable, but only at one specific place on Earth. If you happen to visit the south of the Gulf of Carpentaria between late September and early November, specifically a place called Burketown in Queensland, Australia, you'll observe what the Aborigines call, and you have to bear with me here because I couldn't find the exact pronunciation, but something along the line of kanongi. Nowadays, what we refer to it as are the morning glory cloud. It's an extremely rare yet predictable row of roll clouds, and that is what we have here. These are the
So
morning
nice.
glory clouds above Queensland, and each of these are in fact roll clouds.
Yeah.
Now that brings us to next APOD, August 18th. Now, what do we have here? I may have spoiled the thing a little bit here, but what we see here is something called the Lowell Region. It's named after Percival Lowell, the founder of the Lowell Observatory. Established in 1894, it is one of the oldest observatories in the US and was the site of a very significant discovery. 12 years after founding the observatory, Percival began searching for a hypothesized ninth planet in the vicinity of Uranus and Neptune. You see, when Aubin Le Verrier discovered Neptune after analyzing the orbit of actually, I think it was the other way around. I think he discovered Uranus by analyzing the orbit of Neptune. He calculated that a third object was actually necessary to complete the whole picture of Uranus and Neptune's orbits to accurately match observations. And Lowell spent the remaining 10 years of his life surveying the night sky in search of this ninth planet. He did, in fact, capture a ninth planet in 2 photographs back in 1915, but the object was incorrectly identified. Anyways, after his passing, Lowell's wife engaged in an extensive legal conflict over the observatory, causing the pursuit of this ninth planet only to recommence in 1929, at which point the observatory director appointed Clyde Tombaugh to resume the search. And on February 18th, 1930, Tombaugh found the ninth planet. And
Wow.
on March 13th, 1930, after further confirmations, the discovery was announced.
Yeah.
Now, some of you may know what this planet is, but for those of you who don't, 3 days later, 3 days after the announcement, Falconer Madden, the librarian of the Bodleian Library, which is the primary research library at the University of Oxford, he was sharing this news with his family over breakfast when his 11-year-old granddaughter, Venetia Burby, casually suggested naming it after the Greek god of the underworld.
Who you?
Shortly after, Madden actually passed the suggestion to astronomer Herbert Hall Turner, the director of Oxford University's Radcliffe Observatory. Turner sent the name in a cablegram to Lowell Observatory. Ever since then, the object has always and will forever be called Pluto.
Wow.
That was the story of Pluto. Now, in a rather unfortuitous turn of events, Pluto ended up not being the object that Lowell was actually searching for. It was supposed to have a predicted mass of 7 Earth masses, but Pluto is closer to a 500th the mass of Earth. But either way, Lowell's contribution to the discovery of this dwarf planet remains recognized. And that's where New Horizons came in. See, carrying with it a small container of Tomba's ashes,
Oh,
the New
no.
Horizons spacecraft surveyed Pluto back in 2015, and upon taking photos of Pluto's northern polar cap, researchers named this region the Lowell Region. This specific photograph was a compilation of data collected in July 2015 by New Horizons, which was part of NASA's Frontier program. That's why you see NASA there as part of the credits. It was constructed by the Southwest Research Institute in San Antonio, Texas, hence, as you can see here, Southwest Research Institute, and also the Applied Physics Laboratory at the Johns Hopkins University in Laurel, Maryland. That brings us to my third APOD, August 15th. Let me zoom in here because you really need to appreciate the magnificence of this. For my third APOD tonight, I present to you 3 distinct natural and artificial phenomena. In this wide landscape shot by Violetta Goretzka, who organizes photo trips with
Fantastic.
agencies, and is briefly described in this caption right here by Natalia Lewandowska, an assistant professor and director of the planetarium at the State University of New York at Oswego. This APOD showcases, this is the description here from Assistant Professor Lewandowska, but what this APOD shows are 3 truly remarkable sights. Going from subjectively the least to the most exciting effects, let's start in the middle here with the, let me get this name right, the Fagradalsfjall, an active volcano just 40 kilometers away from Iceland's capital city of Reykjavik. Iceland is the most geologically active place on the planet, hence its nickname, the Land of Fire and Ice. And the Fagradalsfjall is no exception. It last erupted on the 10th of July this year. And in this image, it can be seen emitting a volcano's iconic volcanic gas, comprising water vapor, carbon dioxide, sulfur, usually either in hydrogen sulfide or sulfur dioxide, in addition to nitrogen, argon, helium, neon, methane, carbon monoxide, and various other compounds. Now, due to the tiny sulfate aerosols, they actually scatter the blue light coming from the sun. That's why oftentimes when you look at a volcano's plumes, they appear to be orange in color. Now on the left here, we have something a lot of us are very familiar with, the Northern Lights, Aurora Borealis. And what's basically happening, as some of you may know, is that highly energetic particles from the sun are coming into contact with the thinner parts of Earth's magnetosphere. And when that happens, they emit photons of various wavelengths, depending on the atmospheric constituents involved. Here, the green light is visible due to solar particles colliding with high levels of oxygen at these altitudes. Red usually comes from collision with lower levels of oxygen at higher altitudes, and blue usually comes as a result of collision with nitrogen. Now, finally, all the way on the right here, we have the artificial side of things. Now, why do I say that? These are the white plumes of the Svartsengi geothermal power plant. Established in 1974, its turbines have been running using the fresh water and seawater that's mixed in volcanic aquifers. This water, after being run through these turbines, which in turn generates electricity, they form the iconic Blue Lagoon of Iceland. Right here. It's a hot spring spa that brings in about 700,000 people every year. This is the Blue Lagoon. And yes, these are waters that are run through the turbines at a power plant. And with that,
Ray, I feel that even a very imaginative artist cannot paint a picture as imaginative as the photo. So
That is
nice. It's not only scientifically correct, it's very nice also, very aesthetic. Even the imaginative artists also cannot paint like that. Yeah.
true. Oftentimes, fact is way cooler and way weirder than
Yeah.
fiction is. And with that, I move on to my last APOD, the APOD for August 10th. Now, this is a rather big picture, so I'm going to have to zoom out quite a bit here. We see the image credits, and immediately we know what this is about. NASA, JPL, at Caltech, the Jet Propulsion Laboratory at the California Institute of Technology, and Ingenuity. On August 3rd, the 872nd Martian day of Perseverance's mission in the Jezero crater, its little sister, Ingenuity, nicknamed Ginny, took off for her 54th flight on Mars. During this flight, she successfully hovered above Mars at an altitude of 5 meters for 25 seconds before safely returning to the ground. Now, this was a rather interesting milestone because it followed Ingenuity's 53rd flight on the 22nd of July, where it had an unplanned landing. You see, it performed the initial flight, traveling at an altitude of 5 meters for over 140 meters. I think the total distance it covered was something like 142 meters. And then a flight contingency plan was triggered, and Ingenuity just landed. The total flight time ended up being 74 seconds. What happened was that, you see, every flight has a program called Land Now that's included in the flight instructions. And what that basically says is if such and such unusual situation is encountered, you detect this, you detect that. If one of a dozen or so scenarios are encountered, Ingenuity is supposed to safely land as quickly as possible. And during Ingenuity's 53rd flight, it encountered one such scenario and hence executed the program as it was planned and as it was built to do. And our Ingenuity here is another prime example of girls at young age coming into naming things in astronomy. Veniza Rupani, she's an 11th grader from Alabama. She was the one who actually submitted the name Ingenuity to NASA's. I think it was still part of the Name the Rover competition, but this was specifically for the helicopter. So if there's anything to take away from all these, it's that there really is no age limit to astronomy. And with whatever your age, if you're interested in it, explore. I mean, that's what I did. And who knows, maybe you'll be presenting for the Astronomical Society of Penang, or even better, maybe you'll be announcing the next big thing to come out of the International Astronomical Union. Thank you. I shall pass it over now to, I believe it is
Yunming.
Winwei?
Yunming.
Ming. Okay.
Yunming.
Thank you, Ryan. I'll be presenting about now.
Okay.
So this is so this is the first APOD picture that I'll be presenting, which is the August 16 APOD. And it is called ARP-93, A Cosmic Embrace, by Mike Selby from the Source Observatory in Chile. So what the picture shows is the collision and possible future merging of two galaxies in the direction of the constellation of Aquarius, in which we know this system as ARP and ARP-93, and the galaxies involved are NGC 7285 and NGC 7284. Now, when we see the name, we notice that the numbers are very close to each other, and this is the case, especially for the later NGCs, because the later NGCs, those in the thousands, are discovered in batches and they're all in the same or in the same region of sky. So that's why you have neighboring NGCs with neighboring numbers. So when we see or think of galaxies colliding, we may think of the fate of our own Milky Way and Andromeda galaxies that will happen in the distant future. And the merging galaxies happen when two galaxies move towards each other and they collide. So in this process, the nuclei of the galaxies, the central bulges here that we see, they are usually rotating or revolving and have angular momentum already. So when they approach each other, they would attract each other with a relatively strong gravitational force, and this would distort the galaxy because different sides of the galaxy experience different gravitational force, and this would stretch the galaxy, and we end up with a tail that we can see here, the whitish line in the center of the picture. And at the same time, as the galaxies revolve around the common center of mass, the tails, well, there's only one in this picture, but the tails, they will gradually straighten because there is a reduced gravitational force, a reduced centripetal force at the same time, and there is a lesser correcting force that changes the direction of the tail. So the tail ends up getting straighter. And after a few collisions with each other as they rotate, the galaxies will collide. And after a few repeated cycles, which may take hundreds of millions of years, the two cores or nucleus of the galaxy, they merge to form a singular larger galaxy, and material from the tails, they would converge to the nucleus, and that's how we get new galaxies. So I move on
Yes.
to the next APOD, which is the August 14 APOD, which shows the Ring Nebula in infrared. And this is by NASA, European Space Agency, Canadian Space Agency, and of course our favorite JWST. And this picture processed by Ziyang Kong. So the Ring Nebula is a very famous nebula, which many people with a telescope can see even in our Malaysian sky. So over here it appears very colorful and
So beautiful, very nice.
yes. And
Wow.
the Ring Nebula is known as the M57 in the Messier catalog and MGG 1720 if I'm correct, which is part of the New Galactic Objects or New Galactic catalog, which was the catalog that we mentioned earlier on for the two galaxies. So for this nebula, it is formed when stars expel envelopes of gas, which forms our ring, which appears orange here. It expels it in shells, so it appears one complete ring. And from this picture, we can tell that it is taken by the JWST because in the stars on the bottom left and the bottom right of the picture, we can see the six-sided spikes that is due to JWST's diffraction effect. And at the sides, you can also see loops of purple and orange, which are strings of filament of gas, strings of filaments of gas, which is caused by ejected material of the central star in the blue region. And in the process of taking a picture, in infrared light is shadowed by the purple loops, and that's how we see the purple loops. And the Ring Nebula is a planetary nebula, and as I mentioned, it ejects material. Of course, we can find this nebula near the constellation of Lyra, in which the star Vega is quite near. Well, Vega is quite a famous star because it is close to the zero magnitude of star brightness. And well, the pictures over here, as mentioned earlier on, it appears quite colorful because it is colored according to the infrared spectrum. If we use our naked eye to see, we would probably not see this, but instead a more subdued color. And go on.
Really nice
It
picture.
shows the
Fantastic.
yes, it shows the Sombrero Galaxy, which is by Connecticut, SSC, JPL, Caltech, and NASA. And again, same with the previous NGC or Messier object. It appears very colored here because it is based on the infrared spectrum, and color is given to it. And this galaxy was found in 1818, in the year 1818, and we can find it in the galaxy cluster, which is called the Virgo cluster galaxies. The Sombrero Galaxy itself is a galaxy, as the name suggests, and there are many globular clusters in the central area, the bright blue area that you can see. And globular clusters are groups of stars that form usually during a singular event. And at the same time, like our Milky Way with the M87 black hole, the Sombrero Galaxy also has its own supermassive black hole in the center of the galaxy. And speaking of massive objects, this galaxy is also known as M104, which is 104th massive object, and there's a NGC 4594, which is relatively old since, well, even though it says New Galaxy Catalog, the catalog's relatively old, with it being published in 1888. Although this galaxy was found in 1781, which is quite a long time. And well, it appears quite nice here, even though in the visual spectrum, we would see a very dark band right in the center, where now we see it as a very colored band. And speaking of Messier objects or NGCs, these lists were created to catalog objects. The Messier catalog was to take note of celestial objects that were not comets, and the NGC was created to catalog different celestial objects in the sky. And NGCs or Messiers, these catalogs have thousands, if not hundreds, of celestial objects recorded. And then I guess that's it for celestial objects. And we now go to a more fun topic, which is in August 12th, which is last April I'll be presenting.
So nice,
It shows-
beautiful.
Yes, it's very, very beautiful. Very, very creative.
So nice, you know.
Very creative.
Creative.
It's
I'm
like
gonna ask Yun Ming at
signature
the end,
or what?
Maybe I ask him first. How did you create such a nice series of funny doodle? How?
Well,
What do you
well, when
understand?
we normally take long exposure photos of stars, we would move the telescope to counteract the effect of the Earth rotating or rotating, so that the star appears as a singular dot in the sky. So, in the sense, the telescope moves no distance at all with respect to the star in this case. And if we let a telescope be in a singular position for the whole night, we would see many star trails surrounding the north celestial pole in our case. But if we do it from Malaysia, we'll see long arcs in the sky, since we can't exactly see the north celestial pole from here. So we end up with long arcs in the sky formed by the stars. So
So
in this case,
beautiful.
so in this case, the telescope moves with respect to the star. So we can conclude that if the telescope moves with respect to the star, in this case, in the picture, then we'll end up with a line. So what if we manipulate the way the telescope moves with respect to the position of the star in the image? We'll end up with these very creative drawings. But of course, you might wonder, how do we move the telescope with respect to the position of the star? Well, since telescopes focus on a very small area of the sky, so any very sudden movements would move the star out of the image. So therefore, a singular light tap is enough to change the position of the star in the picture and form a singular line in a singular direction. So, for example, this line with the loop is probably caused by someone tapping the telescope, and the telescope moving slightly in the direction shown over here.
So Yun Ming, just give me an idea, no? Kapasing Drive. Come and touch my telescope. Come and hit it. Ping! Vibration. Some of them are actually our famous Lisaggio figures, frequency. So you knock it, and when it's vibrating and coming back like a closed circle, you take a long exposure, or even you take a video and later make a picture. Very nice. 25
Yes.
stars here, different color star, hit in a different way. So nice.
Yes, that'll be very, very nice. Although if you hit it too hard, you will escape the picture, but that's very, very good idea.
Yeah.
And well, when we draw it out in lines, we can see it has different colors, which is
Yeah.
due to the temperature of
The
the
star. Yeah.
star. Yes.
So nice.
And well, I think you probably know, but each of these pictures are formed individually and then added onto this picture. Since at one time you can only draw one picture with the stars inside the telescope, since the telescope's only moving in one direction.
Yeah.
Yep.
Just one idea, Yun Ming, if you can relate those wiggly lines into sound, the waves, so you can each let's say the top left hand side you have a certain tune. Second one is a different sound. You play. This is the stars singing. So nice. And you know, these Italian people are very imaginative. No? So this Italian guy very imaginative to create these images. And every every image is from a star with a different color. Yeah.
Oh, perhaps because the longer the exposure, the brighter the image. So
Yeah.
if it moves slower, if it vibrates less, then the
Yes.
more light will come in and it become relatively brighter.
Yes.
So
Yes.
yes, that's a very good idea.
Yeah.
And right, I guess this ends my APOD sharing for this month. And right, I'll pass it on to Boon Wei.
Yeah. Thank you,
All right.
Yun Mei.
Hello. Thank you.
Boon Mei, you want to start or you want me to start? You follow the
I
script?
can start first. Am I?
Okay, you start. Okay.
Yep. Let me share my screen first. Okay. Can see my picture now?
Yes. Nice.
Yeah. My my first APOD to present today is the 8th of August picture. So let's see what is the picture of the day today. So here's the moon. So let me scroll down. Is Jupiter and the moon's there. So the caption for this is moon meets Jupiter captured by Spain photographer Jody Altroy. So in the mid of June, there's an astronomical event of the close conjunction of the Earth Moon passing nearly in front of the Jupiter. So this featured image is a single exposure of the event taken from the Moron de la Frontera, Spain. So it's the hometown for Judy lah. So the living space for the Jody. So this picture, you can see there's a bright part and also a darker part. So the bright part is actually the sunlit area of the moon. So it's like 16.5% of visible, and so it's a so bright, so it's actually an overexposed already. So here is the dark side. It's actually illuminated by the earth shine. So you can see a very clear moon face here, the shadow, the volcanoes on the moon. Yeah, so in this picture we can see actually total 5 moons here. The the moon of the earth, and then the 4 moon from the Jupiter. Yeah, the Callisto, Ganymede, Io, Europa, others.
Very
These
nice.
these 4 Galilean moons. Yeah, so the Galilean moon is actually the first celestial object that discovered by the Galileo Galilei. In what 16 of 1610. Yeah. So in fact, Callisto, Ganymede, Io is actually larger than our moon, but it's far, so it's showing quite small. Only the Europa is slightly smaller, and the Ganymede itself is actually the biggest moon in the solar system. Yeah, the size is even larger than Mercury. Yeah. So okay, caption here: NASA robotic spacecraft Juno is also currently orbiting Jupiter, and also it made a close pass near Io on the Sunday, July of 30th of July. So Io is most volcanic active in our solar system. So the data collection by Juno is expecting to get 100 of erupting volcanoes pouring out molten lava and the glass over the moon. Yeah. Then the data, of course, will be analyzed by the Juno mission research team. So this is the picture of the 8th of August. Very nice composition. Yeah. So I think it's so I think near the 8th of August is also another moon Jupiter conjunction as well. All right, so I'll go to the next picture. Okay, my next picture is moon rays of August. Yeah, wow. I thought initially if looking at this image itself, I will thought this is the sun and the rays, but no, this is a moon ray on the 4th of August. Is actually happened during when the full moon rose and when the sun is set on August. So this picture is taken by Gianni Tumino. He's an amateur astronomer from Ragusa. So the moon now is at near perigee. So it's the closest point in its monthly orbit. So is also will be brighter than average lunar disk that illuminated around the Earth, planet Earth, because this is actually the second supermoon in 2023. So this is taken in Ragusa city, the city, and you see the the cloud banks actually cast diversing or the shadow of the moon, the supermoon lit. So you can see the rays here, and the rays is the columns of light that appear to radiate towards the light source. But normally we will see is the sunlight during the twilight time, and then it was like enhanced by the Rayleigh scattering effect. So very beautiful, very rare image as well. So this month is also another is also the moon, the month of the blue moon. So so the next full moon is also on in this month, happen in this month, rising on the 30th of August. So um so the second full moon in a month, normally we call it as a blue moon, because and then the blue moon is occurs only very rare, very rare, is every 2 or 3 years, because of the lunar phase is only like takes almost a calendar month of 29.5 days to go through one complete cycle. So this blue moon is also a supermoon. It's the third supermoon in 2023. So probably can make a wish on that day because I heard that the blue moon is always said to be full of luck and the magic to make wish. Yep.
One more thing, Boon Wei, I understand 31st of August also supermoon, you know, Medica Day. Medica Day we also got supermoon.
Yeah. It's
Make a wish. Yeah.
make a wish. Yes. Okay, cool. So I will go to my next APOD. My next APOD is the 3rd of August. Yes. So this is the 3rd of August APOD taken by Matt Haskell, the Falcon and the Redstone. So the photographer Matt Haskell is he is a NASA medical support and also the firefighter, and also he always publish the aviation and the space photo journal. Okay, so this APOD is showing the Redstone rocket and Mercury capsule on display at the Cape Canaveral Launch Complex 5. Yeah, from the early hour of July 29 UTC. So Redstone is actually an old rocket. So one of the most historical important development in United States rocket technology. So he has a very historical launch of this Redstone rocket. Is he carried the astronaut Alan Shepard on suborbital space flight to altitude of about 116 miles. Yeah, so this is called Project Mercury, and also the first human space flight program in US. So the success laid the groundwork for another Project Gemini, which carry 2 astronauts in each capsule. Then the next one is the Apollo launch. So beyond the Redstone, you can see this line. The 8-minute long exposure is capturing the arching launch track of the SpaceX Falcon Heavy rocket. So the Falcon Heavy communications satellite payload is actually bound for the geosynchronous orbit about like 22,000 miles above our planet Earth. And then another one is the another Falcon rocket is a 2 reusable side booster, and then they actually return to the land site. Yeah, at the Canaveral landing zone 1 and 2 in the distance. So today, actually there's another Falcon, the Falcon 9 rocket also launching the third pair of the broadband internet satellite into the medium Earth orbit as well, from the same Cape Canaveral space station at 5:04 p.m. EDT. So on the 27th of August. Yeah. Okay.
Nice, very nice.
Yeah. Okay, so I go for my last picture, which is on the 1st of August. Monster solar prominence. Yeah, looks like a monster. Monster solar prominence. Okay, so very very nice. Okay, Mike Vance is this picture is taken by the Mike Vance, and he is a lead system engineer of the optical telescope assembly on the Hubble Space Telescope. So he actually referring this solar prominence as a monster that living on the sun. Yeah, very larger than Earth, and then also having many tentacles. Like this picture, you can see there's lots of tentacles. Yeah, so this picture is taken by a small telescope in Gilbert, Arizona, USA, using the H alpha light of hydrogen. Okay, capturing during the mid of July. So yeah, it can say that it's saying that this picture got the gas and then held aloft for the ever present, and then it's also changing of the magnetic field, so near the surface of the sun. So okay, so solar prominence is a ionized arc of gas, so also catch by the magnetic loop and then right out from the outer layers of the sun. So yeah, just now saying it's larger than the Earth. It is the size of the typical solar prominence is around 10 times the diameter of the Earth, and then sometimes it actually can last a few minutes, and then some is several months. So usually they will like slowly change the shape and then fade back to the sun about a month. Depends on its active or the quiescence. Okay, so also this one, because is caught by the magnetic loop, and then sometimes it actually will explode and then also unleash the energetic particles into our solar system, and then also might attack the Earth. So recently the sun is actually very very active, so it's showing a very unusual number of the prominent, and then also the solar activity like filament, sunspot. Yep, and the solar active maximum will be approach to 2025. So I believe upcoming APOD will have a lot of solar imaging image. Yeah. So that's all from me.
Wait a minute, hold on your picture. Moving to comment. This morning, our Yaya Basiron, one of the IAO 2023 Malaysian participant, he was going to go to Beijing in November for IAO 2023 in Beijing. He was in Penang, and he took the hydrogen alpha telescope. He imaged it, And there are two small prominence, much smaller than that, very small one. And he was so excited. If only you could see like that, he go to Pengsal, I have to revive him and call the ambulance to come. Small one, but clear lah. But this is really gigantic. Now you
This one
mentioned,
is very big one.
yeah, huge. And so once in a while, we have seen that in Tech Dome. And our member CK will sometimes call me, John, I'm now in a school in Batuan. We saw with the hydrogen APOD particle a big prominence. So I rushed back to the USM museum with the hydrogen APOD particle. Sure, there's a bright one. And you mentioned about 2025. So by the way, some of our ASP members, they're now still deciding to see, because 2025 is solar maximum, also aurora maximum. 3 places, either to go to northern Norway, or even more fantastic, northern Canada, or South Island, New Zealand.
South Island, New Zealand. Okay, I should plan the trip to the New Zealand now.
Yeah. So even now, there should be aurora in southern
I think the aurora is quite.
The place that they usually observe in South Island is Invercargill, South Island, New Zealand. So our members are planning 3 possible places. I see whether I can join them, but very cold. You go
very cold, yeah.
Or Northern Territories, Canada. Yeah.
Okay, that's all from me. Dr. Chong, any add-on?
I think, yeah. I've add on my picture. Okay.
Yep.
I share my screen now.
Okay, and let me stop share first.
Okay.
Right.
Thank you. A bit slow.
Oh.
Okay, slowly. Yeah, entire screen. Share. There you are. Okay. Can you see my screen now? Move away.
We can see.
Yep, can.
Can you see, Okay,
Yes.
Yeah, everyone, thank you. So now this is a big one. I will make it smaller later. So this is August 19, all right? And then, okay, I'll read it out now. Ring Ice Giant Neptune. So by NASA, European Space Agency, Canadian Space Agency, SCSCI is the famous Space Science Telescope Institute in Johns Hopkins University, Baltimore, Maryland, and near-infrared camera of James Webb Space Telescope. And then the moment you see, like our Yunming's earlier picture of the Ring Nebula, you see this thing, 6 spikes with these two here. So basically you have here the planet Neptune, and then the brightest moon of Neptune called Triton, Triton, and you have the famous Webb spikes, WEBB. Webb doesn't mean spider web, James Webb Space Telescope. So now we have to get familiar with that. Previously was Hubble. Now it's Webb. So you have the hexagonal shape of those mirror, segmental mirror, to create the 6 bright diffraction spikes. And then you have two smaller diffraction spikes due to the secondary mirror holder, the 2 beams. So altogether you have 8 spikes here. And now I make it smaller. There you are. And then you see here, of course, you have Neptune here, and they call it ice because it's very cold. Remember the Voyager 1 and 2 mission flyby of Neptune years ago in the 1980s. They took a lot of pictures of Neptune, and they found, of course, the rings of Neptune. And Neptune also got, I understand, they say here what? 14 moons, all right? So you have seen here the brightest moon, Triton, is already so bright, okay? So this is really, really fantastic. And of course, you have seen the other stars here also, okay? So now we know that the planets in solar system that have the rings are Saturn, Jupiter, Neptune, Uranus, got rings, all right? And even the sun also got a ring, stretching the whole solar system. And it formed the zodiacal light, all right? And you see that the Triton, the moon of Neptune is so bright that the diffraction spike is so bright. And because that, then you may say, how come the Triton, the moon of Neptune got diffraction spike, but Neptune is brighter, no diffraction spike? Can be explained. Because Neptune is an extended object. Only a point, like a bright moon or a bright star, will give diffraction spike. Even in the lower right side, this object also got diffraction spike. But Neptune don't have because it's an extended object, right? So this is a beautiful view of what we call Neptune, right? Taken from James Webb Space Telescope. So we have to get ready in future more and more Webb pictures. And I feel that many of the pictures by Webb are so what is called astounding, with a lot of scientific data. Maybe in some years in future, they will win the Nobel Prize in physics, but in astronomy, based on the results from James Webb. Okay, so please pay attention to the data of Webb. And our ASP also, as well as Penang, our Mr. Kenny Low has started a chat group. You can come in, which is Kenny Low, Dr. John Su, I think Dr. Idawati and myself. We are now going into the James Webb, the pictures, archive pictures, and the catalog to get a lot of data to see whether we can use our own research on the data archive of Webb. You are welcome to join us. We have formed a group about 6 months ago already to look at the data of Webb to see whether we can do some research on it. Because now the big telescope in space are getting so much data that the professional astronomers have no time to analyze. So they put it on the internet, distributed or citizen science that we can contribute. Okay, so if you are willing to join us, you can join us. Okay, so the next one is November the 9th, no, August the 9th. Again, Percy meteor shower. All right, and of course, this is by our famous. Of course, it's a Czech word, but I pronounce as English. Peter Horalik. Now, Peter Horalik is very famous, just like Professor Druckmuller. He's an amateur astronomer from Czech Republic, and there's a small observatory in Slovakia, and he took the meteor shower. Now, of course, the moment you see a meteor shower, you need to say, Rayan, you open your camera, you get no long exposure, guys. You may have to open for a long time, and then after some time, there you are, the one bright one here, fireball, and another one 10 minutes later. This could be after many years of exposure. And what I like about this picture is, see, Perseus is near the top, and he positioned the meteor shower that the meteor showers are pointing downwards, following the plane of the Milky Way and away on both sides. So very artistic composition. But if you put a Milky Way like angle in an angle, not so nice. But just like that, Milky Way is up and down, and the meteor shower from the radiant is pointing down. Very, very artistic, So very nice. Except that we have done a lot of meteor shower observation before. One thing can be like that. Mr. Peter Horalik, maybe he's married with his wife or girlfriend, should stand below there. Meaning that maybe for about 5 minutes they don't move, and they're also in the picture, and they open up their arms like that to catch the meteors. It's possible. When you take a landscape astrophotograph, some of the people put themselves in the picture, and it's as if they're catching the meteors, all right? And maybe they will be making wishes from their mouth, because a lot of meteors can make a lot of wishes. I really like this picture by Peter Horalik, our well-known astrophotographer from Czech Republic, all right? We go to the next one. 6th, the last one of August. This is serious. What is this? Okay. Again, you may say it's a very simple piece of art. In a sense, it's true. But basically, it says that SN mini supernova 1005. That means it exploded in the year 1005 AD. A supernova ribbon from Hubble, taken by Hubble years ago. And you see it's a twisted thing. So basically, the supernova exploded more than 1,000 years ago. 1,000 years later, today, 2023, is still expanding. All right. So this is expanding empty space, and it seems this diameter of this supernova is many light years. The other stars are behind. Okay. And you look carefully, there you are. There are 4 spikes. When you see 4 spikes, what? Hubble. You see 6 spikes plus 2 small spikes. That's Webb. Okay. So very nice. And I would say I have not really looked too much into the astrophysics of supernova, but I understand that when a star goes bonkers, like Betelgeuse or Antares, they're the rich supergiant. When they explode, the expansion is still occurring for a long time. So it's very, very violent place to be. Imagine the supernova explode maybe after many hundreds of years, very hot, and inside the supernova, a lot of inside the expanding supernova, a lot of what? X-ray, maybe some residual gamma ray, strong radio wave. So don't go into a place where the supernova is expanding after hundreds of years. Very intense X-ray, maybe gamma ray, radio wave. You want to use your handphone? Cannot. There's so strong radio wave that you cannot. The background is so loud, the radio, it will drown out your handphone signal. All right. So maybe I'll be feeling that although this supernova remnant 1,000 years ago exploded, may be still quite dangerous to go to. Right. But very nice. But if you do follow this supernova remnant over the other parts of the space, it actually extends over large parts of the Milky Way. So we of course know that in the Milky Way there are a lot of supernova, right? In the past supernova, and we also know that the astronomers estimate that on average, there should be a supernova exploding in Milky Way galaxy every 100 years. Because the Milky Way got 200 billion stars. So on average, one supernova explodes in Milky Way in about 100 years. But remember, there are billions and billions of galaxies. So some astronomers estimate that maybe every second of a lifetime, a supernova explodes in some galaxy far away, right? So this is a remnant of a supernova explosion, supernova SN 1006. All right, beautiful picture from Hubble. All right, now this one you may say, are amateur astronomers able to take this type of supernova remnant? Many of them have taken, like the Vela supernova remnant in the constellation of Vela. But this one, I don't know whether amateurs have taken. But very nice, no? You can take a picture of a supernova remnant. So if you wait long enough, what happened to this ribbon? The answer is disappear. You expand into empty space, and then the ribbon become more and more diluted. So maybe after about 10,000 years, it's gone. The remnant is gone, right? But right now, 1,000 years later, after explosion, it's still there. It's twisting and still going on. And I suspect, don't go near there. Strong radio wave, maybe even strong X-ray, all right? You cannot use your handphone inside there, okay? So that was my last airport picture, okay? Maybe we can have our final comments. Okay, so everyone here, Junming, Ryan, Bunwei, any comments?
No comment.
Okay. So I checked our YouTube channel and the Facebook page. I don't see anything yet about half an hour earlier. Any comment now? You'll see.
The comment is very cool, I think.
Yeah. What's the comment again? Any question?
No question. Just wonderful picture.
Yeah. Now you pay attention. In some of the picture presented by you and myself, they always mention SCSCI and JSU. All right, like the last one of the SN what you call 1006, because the Hubble Space Telescope, controlled by Space Science Telescope Institute in Johns Hopkins University, in University of Baltimore, which is just on the outskirts of Washington, D.C. So I'm very sure now, many of the young astronomers in America and around the world want to do research with what? With Webb, with SCSCI. So if ever you go America, Rayan or Yunming, visit there. It's Johns Hopkins University, and the SCSCI inside there. So SCSCI is controlling two things, still controlling Hubble and now controlling Webb. All right. So in the years to come, I'm sure that the pictures by Webb will be as groundbreaking and as many as that of Hubble. I've been following Hubble since it was launched, in 1991 or something. I was so excited. We were waiting for Hubble for 10 years. 1981 talk about it, 1991 launch. And then no news. And then about 6 months later, the first picture came. Oh no! For the very bad picture of Whirlpool Galaxy. So they said that they found that there's a flaw in the shape of the primary mirror of Hubble. Very bad spherical aberration. So I told myself, what, you spend so much time using tests of technology? And they found the reason, So if the primary mirror was cast by Corning Glass Company, your Corning there, the Corning hard glass, and they have some rods to hold the primary mirror when they do the testing of the parabola. Something problem with the rod. But then, surprisingly, a few years later, the scientists were engineers, they have a solution. Play with the secondary mirror, a hyperbolic mirror. So primary mirror, you cannot do anything. 2.4 meters, maybe many tons, So they changed the secondary mirror, and the advantage of the Hubble Space Telescope is that you can have repair. So there's this harbor space design is modular. Just like in Penang, in Malaysia, you know, the multinational many years ago already, like Boon Wei said, some problem with some kind of equipment in the company. No problem. Pull the module out and push in a new one instantly. But you take it out and repair for 10 days. How much money they waste, downtime. So the same thing for harbor. Pull out the bad thing and slide in a new one. So they did it, but they needed the space shuttle to do it. So when the space shuttle no more, they cannot repair. What about web? Sorry guys, web is 1.5 millimeters away, cannot be repaired. So already we know that there was a meteorite that hit the primary mirror of web. We hope no further damage. Right? So we are waiting for web. So please pay attention. If you go to a state, or maybe who knows, you pursue a career in Johns Hopkins Space Telescope Science Institute. All right, okay. So any final comment from you all?
Actually, still talking about JWST, there's another incident that happened where I think it was a cosmic ray that hit one of the infrared detectors, and for a while they weren't receiving the data right. It turned out all the scientists had to do to fix it was turn off and turn back on.
Yeah.
Reboot, and you're able to fix it.
Actually, Wayne, this is another issue. The Webb telescope is not protected against the meteoroid. The full force on the Earth's atmosphere block all the meteorite, burn in the atmosphere. That's why your meteors, random meteors, and the meteor shower. But also the cosmic ray is not protected by the Earth's atmosphere. So whatever, let's say the fast-moving proton, hits the upper part of the atmosphere. By the time it comes down to the Earth, it creates a trillion secondary shower, very slow speed. But in space, the cosmic ray is at full energy. But likely, like you said, it hit the software, whatever. But no way, what you call cosmic ray is that powerful like to knock it out and create a hole. Although years ago you saw in Wikipedia that years ago in America they have the so-called Cherenkov cosmic ray detector. They detected the most powerful cosmic ray particle. It seems that single particle could be a proton or a neutron or what? No, proton or ionized nucleus of an atom came in. It's as if you're smashing a tennis ball at 200 kilometers per hour. Just a single atomic particle, the energy half mv squared is energy of a 200 kilometers per hour tennis ball. So if you have such a particle hitting the one part of the web, I think can damage. So I think it's all planned for. They cannot do anything about it. All right. So we hope that web will be functioning well for years to come. Yeah. Any comment? Yeah. So thanks everyone for presentation. So Yunming and Rayan, we welcome you to be with us to as long as possible. As long as I find that I learned a lot from here. So in looking at previously I will look at Hubble, and later on Hubble heritage. But now I look at this airport. Because I use the word, since you are Malaysian, I said airport is a rojak website. Rojak in a positive sense. Professional observatory, amateur observatory, not only astronomy, like the weather, the roll cloud in Wisconsin. Anything can be there one. And some of the people who come up with pictures very imaginative. I've never imagined that you that. That's why I like airport. So now I look at airport. Okay. So thanks again. We hope to see everyone again. Thanks Boon Wei also. And thanks Michael.
Thank you.
Thanks for hosting, Michael. Okay.
Thank you,
everyone. Okay.
Thank you, Dr. Chong.
Okay. So the next one is Germany meteor shower in 2